Okay.
All right, I didn't know that.
Okay, let's get started then. So, hi everyone, welcome to our session about monitoring with Prometheus, Grafana, and SUSE Manager. My name is João, and I'm here today with Johannes. We are both managers on the SUSE Manager team, which is quite a large team. We have more than 20 developers, plus QA and documentation. And we started with monitoring out of a need we had in our development lab, in our continuous integration machines. We wanted to understand a bit better how our infrastructure was performing. Also wanted to be able to performance test SUSE Manager and inclusively have some insights on how continuous integration and our test suite was performing. And we tried Prometheus and Grafana with that purpose, and since then we have been using those tools internally. And we found it would be quite interesting to show our customers how that can be integrated with SUSE Manager and how SUSE Manager can help make life easier when setting up those components. So today we'll be presenting a bit about some monitoring concepts, how Grafana and Prometheus work in a high level, and how they can be integrated with SUSE Manager to make their configuration easier. We'll also be doing a live demo on how all those parts can work together and on how SUSE Manager can be used to provision Grafana and Prometheus. So, to start, a bit about observability. It's kind of a buzzword nowadays, but it's still a quite important concept to mention. Because when people think of monitoring, they are usually thinking about metrics, but there is more to it. Logging is probably familiar to most people that work on IT. Distributed tracing should also be, at least if you are working with distributed systems, and you have to understand how a certain request behaves from the moment it enters your system, from the moment your customer gets an actual response, or when it doesn't, what actually failed. And we are going to focus actually on metrics because metrics are the starting point for many things, including understanding where can a problem be and kind of narrowing the possibilities and helping you debugging a problem a bit faster. Metrics are also the source for things like alarms. They're not only used for plotting nice graphs, so it's one of the pillars of observability that can be seen as quite useful. And the fact about observability is that this is only possible if systems are able to externalize what is going on. If you are able to tell the internals of a system without sometimes having to look into the internals. So we need to have components that will expose those internals in a way that is able to be processed by those tools. As I was mentioning, metrics are the starting point for troubleshooting. And metrics are also what will help you understand if your customers are having a good experience in terms of performance, if they're actually being served, if you're having too many errors, if something needs to be done. And good metrics will actually help you to investigate the right things so that you can react according to the problem and not spend time investigating things that are not related. And for this, as I mentioned, we are using Prometheus and Grafana. There are other tools out there, but we believe that this stack is one of the greatest ones, and we'll tell you a bit why we have this feeling. And I'll start with Prometheus. So for who doesn't know Prometheus, it started at SoundCloud, and it was created out of a need. So SoundCloud has a really large distributed system to serve music to their customers, and they were not happy with the existing monitoring solutions. So they came up with Prometheus, which is a time series database. It actually has its own storage engine. And it's quite different from tools like Nagios, for example, in the sense that it pulls data from the agents that are running on clients instead of having those agents reporting to the server. And this is quite useful, especially when it comes to scalability. So it's known that a single Prometheus server can handle thousands of clients reporting and with script intervals that are relatively short. So it scales really well. Also, the fact that Prometheus can be configured in an easy way, and you can surely set things via static configuration, but you have lots of service discovery mechanisms available. So you can use console, you can use DNS records, you can use Kubernetes, and all those are already built into Prometheus. So out of the box, it already allows you to do several interesting things. Also, it's nice to give you an introduction about metrics and how metrics are supposed to work. Specifically in Prometheus, metrics have a format that you can see here. So there's a name, there's a set of labels, and you can have as many labels as you want in theory. There's a timestamp, obviously, and there's a value. It's always a numerical value, a floating point value, so you can't have any strings there. And if you use metrics well, you won't ever need to actually feel like having a string on that place. And, well, about exposing metrics, your systems need to expose their internal state, as we have seen previously. And the recommended way of doing this is actually to instrument your applications. There are several exporters provided by Prometheus for different purposes. One of the most popular is the node exporter that gives you insights about hardware. But if you have the possibility, please instrument your application so that you are exposing exactly what you need in the format that you need. Nevertheless, you have an extensive list of exporters that you can see on Prometheus website, and you can connect to things like Postgres databases, Apache servers, Squid proxies. All those are already supported out of the box. And it's also easy to build your own exporters. Even some bash scripting can create an exporter, because in the end, the exporter needs to just create an HTTP endpoint and put a text format there with a metric name, eventually some labels, and a value. There is also this possibility, which is quite interesting, when you have systems that you cannot touch for whatever reason. Like, there is this system running there that you are not allowed to touch, otherwise you'll break some support, or you can't do any changes there because the responsible team won't let you. So it's possible to monitor systems from the outside using Prometheus as well. This is a component that works outside Prometheus but can be easily plugged in. And it also allows you to measure things at a service level. So you can see from the outside how a certain system is behaving, because things might look good from the perspective of, for example, a node exporter. And actually, due to network problems, your clients are seeing different things. So it's always good to use this on certain situations together with the other exporters. This shouldn't be a substitute for using exporters or for instrumenting applications, so it should be used carefully, also because it creates a bottleneck, but it's an interesting part to be aware of. Also, querying metrics is one of the highlights in Prometheus, and on other monitoring solutions, you can query data, but it's not as flexible. It's far from being as flexible as it is in Prometheus. You have this PromQL language, which is a functional language and allows you to easily group metrics, filter them. It supports regular expressions. It allows you to do really fancy things, so it's super, super powerful. And you can see two examples here of how it can be used. It might look a bit overwhelming at first, but once you get the gist of it, it will be really useful, and it will be used in all the interactions that we have with Prometheus. And to get a bit in detail, so here on this first example, you are mainly getting the total number of requests, which is a counter. It kind of counts the requests that have status 500, so some internal server error. And you want to get a snapshot of the last 5 minutes with an offset of 1 hour, so a slice of 5 minutes of what happened 1 hour ago. And you want to know the rate, so what was the rate of failures that happened 1 hour ago? This is what this expression means. So it can go quite powerful. And you have several functions that will allow you to aggregate metrics, to sum, to do averages. You can have histograms. It's really, really extensive. Also, as I mentioned, it supports regular expressions. So you can do things like this and can use regular expressions everywhere. And yeah, when we see how this integrates with Grafana, we'll see that it's the language that we are going to use on all the interactions. We also have support for alerts, and there is this tool called Alert Manager, which is actually a separate component. Prometheus communicates with Alert Manager to send alerts, and you can actually have multiple Prometheus servers that will communicate with a single Alert Manager, which is quite useful in high availability setups. And Alert Manager will take care of routing those alerts, duplicating, etc. And again, alerting rules are written in PromQL. So if you are familiar with PromQL, you'll easily write alerting rules to understand, for example, if a host is down, if load average is too high, whatever you want to measure. Also comes with several integrations out of the box. Email, obviously, PagerDuty, OpsGenie, other case management tools are also available. There's an extensive list on the website if you are curious about it. And there is also this client tool, AM tool, that you can use to script whatever you want and, for example, create some automation. If this host is down, then execute this procedure. And finally, Grafana. So this is the tool that will make things look pretty. It will allow you to create some fancy graphs. It's found quite commonly together with Prometheus in many scenarios, although you can use Grafana with different backends. You can combine data from Prometheus with data from a PostgreSQL database, other databases as well. And it's fully customizable. So it already comes with many panels that can be tuned in different ways in terms of styling. You can inclusively get more panels from Grafana website. There are quite a few available. And you can develop your own. So there's a whole community working on this, and you'll find very interesting prototypes of components to integrate in Grafana. It also supports templating, so if you want to create a dashboard and actually apply that to a group of servers, it's super easy to do. Now, we have a few questions when we want to put all this together. So how will I use Prometheus? How will I configure my clients? What kind of exporters should I use? How do I get started building graphics? How do I configure all this? Because if I don't have any service discovery mechanism in place, like console, I also do not want to configure all the nodes for my infrastructure manually. So if I have hundreds or thousands of servers, this would be a nightmare. And if we have SUSE Manager, this can be quite different, right, Johannes?
Exactly. So maybe you want to give me the tool. So yeah, as Joao already mentioned in the beginning, we do this because we need it. We use those monitoring tools because we need it for our own, to develop SUSE Manager. So we, for example, want to find bottlenecks, scalability bottlenecks, and this monitoring really helps us with that. And we don't only use Prometheus and Grafana for our own needs, but also we use SUSE Manager for our own needs. So we use SUSE Manager to manage our own servers that we use for CI purposes, for example. And I will just try to explain you why SUSE Manager is the right tool to control monitoring in your environment. So many of you are already familiar with SUSE Manager, so there's only a very short introduction here. So it's the systems and infrastructure management solution offered by SUSE since 2011, since I started working at SUSE. Most of our customers would probably run it on-prem, but you can also run it in clouds, on virtual machines. You can manage systems in your own data center, but also in clouds, everywhere. It basically supports all kinds of architectures and operating systems, SLES, Red Hat, Ubuntu in the meantime, you know that. So another interesting fact, SUSE Manager was based on Spacewalk in the past, which is still the upstream project of older Red Hat satellite versions. But in the meantime, we friendly forked it into the Uyuni project. You can see a link here if you don't know it yet. So reason for that was that we wanted to make bigger changes. We wanted to modernize the stack. We wanted to replace the backend with the open source Salt. And the reason for that was that we wanted to offer better features for customers. So Salt, with the states in Salt, it allows you to describe the state of a system. And as soon as you apply the state, you can make sure that system is compliant to that defined state. We wanted to offer such features to our customers, so we decided to integrate Salt Open as the backend of SUSE Manager. And we have much more manpower than upstream Spacewalk had at that time, so they were not really interested in modernizing their stack. So that's why now we have the Uyuni project, which is our own upstream project, which is a really nice setup to move forward. Apart from that, in the past, in Spacewalk, there were monitoring features integrated, so hard-coded in Spacewalk. Not many people were really using it, and I think in 2015, this was removed from the code base for a reason. And ever since then, we were basically looking for a suitable replacement to offer monitoring, but not implement something ourselves, just to find the right tool that is a good choice. So, and I think in the meantime, we are here and we have Prometheus and Grafana, which is the right tool, and SUSE Manager has the right backend to allow us to automate the setup of those tools. So that's why we think it's the right time to integrate Prometheus and Grafana. So for us, very important in the beginning was to monitor the server itself, because we constantly want to improve it. We have bug reports describing bottlenecks if you want to manage many systems. So we started with monitoring the server actually, and not the managed clients. So how would we like to enable our customers to monitor the server? It's super easy. We will just pre-install all the required exporters together with the server. So basically, if you install the server, you will already have all the required metrics exporters to give you information, so allowing you to scrape information about hardware, of course, with the node exporter, Java VMs with the JMX exporter, Apache PostgreSQL exporters will be pre-installed to monitor a database, and the web server. And also we have some instrumentation already in the code. So for specific purposes, we already have some custom instrumentation to figure out, for example, at any given time, what is the size of the message queue in SUSE Manager, how many actions are currently still pending, and things like that. And you will be able to see all this in a
And also
graph.
Taskomatic, which is one of the big parts.
Exactly. Jobs in Taskomatic, for example. So the same will be true for the proxy. So whenever you will install a proxy, it will already have the respective exporters installed. Of course, it's optional. You can always enable, disable them as you want. So but it's just a matter of enabling the service. Okay, so how will this work? We basically, what do you need to answer your question from your slide? What components of Prometheus Grafana will you need? Of course, you will need the server software, Prometheus and Grafana itself, and all the metrics exporters regarding metrics that you are interested in. So we will package those things and ship them from SUSE Manager channels. So if you buy SUSE Manager, you will be able to install them. Maybe other products in other teams in SUSE will also provide those packages, but if you have SUSE Manager, you will definitely be able to install them. And the idea is that specific metrics exporters should be shipped together with the respective applications. So it means if you have a subscription for the server applications and you can install the database from there, the respective exporter should be available from the same place. So that we think makes sense. So how would we allow customers to enable those on managed clients? So with the solid states, we basically have the perfect tool at hand to install packages and to enable services, right? You can create a very simple state with the package installed and making sure that a service is running or not. So we are shipping, we already implemented, and we will be shipping a state to allow you to install and enable exporters on managed systems. And we will ship these states as a salt formula, because salt formula is what you want here, because you also want to provide the configuration, and the UI of SUSE Manager supports to configure the exporters conveniently. So we can also make use of other features in SUSE Manager to other existing features to make it easier. For example, you can use the system groups, define salt formula to the system group to have a same monitoring configuration for a group of systems. And the last remaining piece is then the integration with the Prometheus service discovery, which we will show you in a minute from now. So we already have service discovery implemented that works. And the idea is that at the moment it's a separate daemon that you need to run on the Prometheus server. It will connect to SUSE Manager via the API to get the respective monitored systems, and would automatically update the Prometheus configuration whenever a system is enabled for monitoring or disabled. Yeah, there's a question in the back.
Yeah, what exactly are you using for service discovery, and what infrastructure components need to be in place to use it? SLP, but just as an example.
Okay.
Can you repeat the question?
Yeah. So the question is, what components are we using to implement service discovery? So currently we are leveraging on the file-based service discovery that is already shipped with Prometheus. And we have a daemon that contacts the SUSE Manager API and generates JSON files that are then consumed by the file-based service discovery mechanism in Prometheus. Our plan is to transform this into a native service discovery component and extend Prometheus to directly pull SUSE Manager server via its API and generate the target configuration from there. And we also plan to upstream this so that it becomes a native service discovery method supported officially in Prometheus.
Okay, and that exactly is a good start for this slide, because this is what is coming next. So like Joao just described, we are offering to integrate with an existing Prometheus setup. So if you already have the Prometheus server running, you can just run the provided daemon or wait until it is upstreamed and you updated your server so it's available to connect it to SUSE Manager. But we will also implement the respective states to allow you to provision Prometheus and Grafana servers from within SUSE Manager. So some other missing things that are still on our to-do list is so we want to allow you to automatically enable monitoring during the minion onboarding. So if you register a system with SUSE Manager, it should be easy to just use a checkbox to say, yeah, this system should be monitored, and then at least you will get some basic hardware monitoring by just using this checkbox. Integration with Alert Manager, so it would be really nice if also for the alerts you could in SUSE Manager define the respective alert rules. You can assign, for example, for a system group that at a certain threshold of requests there should be an alert for all web servers, for example. We don't only want to provide Grafana, but we also want to help our customers to get started with it by shipping some initial dashboard templates that make sense. For example, a dashboard to monitor SUSE Manager server, which has all the things in the right place. Just to get started. Of course, from there, everyone can go and customize according to their needs. And the last thing here is the encryption and authentication. So by default, metrics endpoints don't support encryption. So we will be working on supporting this as well in the future.
As an option, because in most cases it will not be required to encrypt metrics, but there might be high security scenarios where that could be desirable. So we plan to include some optional support for that as well.
Exactly, and this is what we're going to show you now. So we will show you how the SUSE Manager self-monitoring looks like, how the dashboards look like. We will show you the initial version of installation and enabling exporters on managed clients. We will see how the integration, how the service discovery works that we currently have. Yeah, the Grafana dashboards that we will provide, and also the alerts. A question?
One quick question. When you have exporters that are at the end of the proxies, how are you able to pull the data back to Prometheus through so you have a SUSE Manager that will have Grafana Prometheus installed on the system. I have SUSE Manager proxies, and then the client endpoints there. So you have exporters installed on the client. How do you pull the data back through there?
Let me just make a small correction. The plan is not to exactly have Prometheus and Grafana running on the SUSE Manager server. We'll have some exporters running on the server itself that will provide insight to a Prometheus server that will be running somewhere on your network. So it will be up to you to decide where to run that server. And that server will need to access the endpoints that you want to scrape, either via a proxy or by direct access, but that will depend on your network setup.
Yeah, the problem that I think right now is TMZ implementations. This would be a problem for this. I was just assuming that we pulled through SUSE Manager because this is a direct pathway back to the system.
That could be something we can look at in the future, but that would also be creating a bottleneck. In quite large infrastructure, routing metrics that come from thousands of systems via SUSE Manager proxy can create a significant load increase.
So we are looking into some scenarios, like for example, if you have a distributed environment in retail stores, I'd assume that maybe we don't even talk to every single box, but the branch server is basically your exporter, and it will do some aggregation. And then, I mean, the larger your environment gets, maybe it's the right architecture to have a Prometheus server running on or next to every proxy, because you have all those locations. So yeah, there are different architectures. But yes, I guess we should make it really easy to help you with all the network proxies. Yeah.
That's definitely an option, multiple Prometheus servers. Then, even in terms of alerting, Alert Manager itself is already prepared for an AJ setup, so you can have multiple systems and still a single point for alerting.
Okay, and that's it with the slides. So let's
try
to show you how it works.
So Johannes, I think the cool thing to start with would be to show what is happening on SUSE Manager.
Let's see.
What are the new cool features we have there, and then how all that plays with Prometheus.
Okay, so what we have here, maybe quick.
A quick insight.
It's not connected. No? Okay.
It is. So this is our demo landscape. So we have a SUSE Manager server, 2 minions, and our surveillance server.
Right. So this is the SUSE Manager server as you know it. So let me just quickly log in. And by the way, this is a 4.0 beta 2 version. So you might see some features here that are not actually available yet, like the content lifecycle management, for example. I hope we don't see extra breakage at the moment. So yeah, so SUSE Manager has a lot of features that you might already be aware of. So many features that they don't fit on this small screen even. So in this case, I would suggest can I have a shell on this SUSE Manager server?
Sure, it's already here. And
just to see how it works, I mean, just to see just to show that the node exporter is running, right? So what's the service name again?
Prometheus -node _exporter.
Exporter. Like this.
We actually have several exporters running on SUSE Manager server, not only the node exporter, but also 2 JMX exporters that look into what is happening into Tomcat and Taskomatic, respectively, a Postgre exporter, and yet another exporter that shows SUSE Manager's internal metrics.
Yeah, so it's really just a service. You could, using systemctl, you could easily just disable it, enable it again, or restart it. And maybe we can directly have a look in Prometheus, what is the data that is scraped from there.
Sure, so our Prometheus server was already pre-set up with a configuration to scrape the SUSE Manager server. This will be done automatically in case in the future you use SUSE Manager to provision the Prometheus server. Otherwise, it's just adding a simple rule there. And if you are familiar with the Prometheus interface, you'll know that we have here a way to look at the targets. So this is the list of systems that are being monitored by Prometheus. We have the monitoring server itself here. We are not going to demo anything particular about the monitoring server. We have the SUSE Manager server, which is running the exporters I just mentioned. So we have 5 exporters there. And we have a group here that currently is empty that will represent the SUSE Manager systems, the clients that are managed by SUSE Manager. All the endpoints are up, hopefully. So later we'll show you how once we add the monitoring capabilities on the clients that are managed by SUSE Manager, that this list of SUMA systems below here will contain the hosts that we have there. So Johannes, how can we activate monitoring features on SUSE Manager?
Yeah, I will show you. So as I mentioned before, we are going to ship a salt formula to help you with that. We will just start from the central place in SUSE Manager, the list of systems. So we have only 2 minions here registered, and we don't have a base channel, so we don't see available patches or packages because we want to focus only on the monitoring. So let's just go to the formulas for this system. Let's see what it shows. So we have here, there's a new group of formulas called monitoring. And if we enable it, it will also enable the only formula there, which is the Prometheus exporters, which we need to save in order to see the configuration of it. So we can go to the configuration of Prometheus exporters, and it shows not much at the moment, but as I said, this is in development, and we will continue to add more exporters to this list. It's also being developed in the open, so we can also accept contributions here. And we, of course, we will be open to input from customers and their needs, whatever they want to see here. So this is really just an initial version to see to show what is possible. So basically, you can here enable, disable the basic node exporter and the Postgres exporter as an example. And we do have a database running on the first minion, right?
One, yeah.
Okay. So
we have a Postgres database running there to demo this exporter. We actually will have, in the end, 2 instances of the Postgres exporter running, because one of them is the one running in SUSE Manager server, which is enabled by default, and then we'll have the second one running on one of the minions to resemble a production environment where we have a database server running there.
okay, database name is Zuma. So when we configured it, we would save the configuration that we want. And on the next application of the high state, we would basically roll out this change to the system. If you go here now, we can see what will happen. So in the high state, I can show you now that what will happen is that the node exporter will be installed, as you can see here, and also the service will be enabled. Further below, we can see the Postgres exporter states. So package will be installed, service will be enabled, and the configuration will be there. Yeah, so let's do that. Let's apply the high state. We could also use a test mode in order to not do it directly, just to see what would happen. So in this case, we are sure that we want that. So let's just do it without the test mode. Yeah. And maybe in the meantime, we can do the same for the other system.
Yeah, we could also show what is happening behind the scenes. So we have a daemon running, this SUMA service discovery daemon, that is contacting the SUSE Manager server API every 10 seconds. And you can see that now for minion 1, since we applied the high states, we have the monitoring entitlement, and we have this setting that shows that formulas for both node exporter and Postgres exporter are now active. And as we now apply the same recipe to minion 2, it will also get updated. What is happening here is that this daemon is generating a JSON file that contains the settings to enable Prometheus to scrape those targets. And Prometheus is automatically reloading those settings as part of the native file service discovery mechanism. So it's almost instantaneous to get those insights starting to pop up in Prometheus.
Right.
So is there not going through a context now, for example, what I see we have SUSE server that defines the resources. I mean, resource being the sources for the Prometheus. And then Prometheus goes up with that through the daemon, get those sources. And then we create exporter, like Postgres is one exporter. And And then Postgres, those exporters are then pushing data back into the Prometheus.
Okay.
And
Well,
then we call again Prometheus to give me information. So it's like a loop going from on the same path.
well, there are two main steps. So the first one is actually installing the exporters on the target systems.
As part of the server, right?
Exactly. So when you apply the high state, those exporters will be installed and enabled on the target system. And then there is this service discovery mechanism working behind the scenes, and this system sits next to Prometheus, and
To update the configuration.
to update the configuration automatically.
Yeah.
So, but this happens asynchronously. So this mechanism is always polling SUSE Manager API and asking for the list of systems that have monitoring enabled and which exporters are running there. And it automatically updates the configuration based on that.
Would that not be easy if I have the same exporter plugged directly into the server and ignoring the Prometheus altogether? Because we still see metrics are formed in those exporters. And those exporter metrics are pushed into the Prometheus thing.
Prometheus is pulling the
Pulling,
data.
yeah.
So Prometheus needs to be made aware that there's a new system
Yeah.
to go to and take data from. And that's exactly where SUSE Manager is going to be the central point of information.
So SUSE Manager could directly go and call those exporters and pull the data out of those exporters and show it. So
Not exactly, because that data is in Prometheus format, and we are supposed to put that data into Prometheus because it has the right mechanisms to handle the metrics. So SUSE Manager here acts as a configuration facilitator.
Yeah.
Since
okay, so the metrics are formed in the Prometheus.
Exactly.
It's just the format it pushed in.
Exactly. Prometheus is the entity that will collect the metrics, but we need to tell Prometheus where to collect those metrics and what kind of metrics we are collecting. And this is what SUSE Manager is doing in terms of configuration. Is updating Prometheus configuration and saying, hey, you have this new endpoints that you need to scrape that are running on this hosts on this certain ports. And Prometheus will then start scraping those metrics and storing them in its internal time series database system.
I would be curious to know, how like the metrics are stored on the Prometheus server. How they store the data, how they archive the data in the Prometheus server.
They have their own time series database engine.
It's stored on the file system, or is there a different mechanism?
It has its own format. It has a write-ahead log, and it has a time series built-in mechanism to store those metrics. It mainly stores the differences in the metrics in a way that it takes as less space as possible, and it's easy to query in a much faster way than you would get with any relational database. The internals of it are not so trivial, and that would be maybe a presentation on its own, I would say, because
Yeah, like the
Yeah.
alert manager you showed earlier in the presentation was, I assume that there will be every sort of alert coming into the alert manager. So the alert manager will provide some APIs or some mechanism to archive, delete, or purge those historical data.
And then it's a different.
yeah, it's a different part, yeah.
Basically, the time series database is optimized for speed, not for long-term storage. But you can then hook up Prometheus to another time series database that's more suited towards long-term storage, and there are plugins.
InfluxDB, for example.
Yeah,
You
and
can
then you
do
can
that.
keep all the historic data for 5 years if you want. But the one that you use in the dashboard is optimized for speed, and it will be reset
Yeah.
from or scraped from time to time to not get too big. Yeah.
In most use cases, you'll want the metrics like from last few days, few weeks, eventually, because they will be used to give you insights when something is wrong or what kind of performance you are having on your systems. So you can, eventually, if you need to do statistic analysis, you can have some other system that gets snapshots of those metrics and creates something separate, so you can analyze the performance of your systems over the period of 1 year, for example. Or you can use an alternative time series database to store those metrics. Prometheus would do that, but it's not designed to hold metrics for such a long period. So it would probably hurt performance a bit. The alert manager that you were mentioning is a separate component, and it only takes care of the alerting part. So when there is something that triggers an alert, Prometheus will contact Alert Manager and send a request, say, I have this alert, here is what is happening. And Alert Manager will decide what to do. Is this a critical alert, or is this just a warning? Should this be sent via email, or should this be sent to a case management tool? When should I resend an alert once I sent the first one? This is all decided by the Alert Manager.
Maybe we can show the Alert Manager in a minute.
Sure.
Yeah.
We'll then present an example of a situation where we trigger an alert, and we'll show how this all flows.
Okay, in the meantime, I'm just showing here the state application, that it was successful. All the packages are installed and services are running on the managed systems. Yeah, and by the way, you also see that in system list in the future, because there will be an add-on system type, so you will see monitoring is enabled for those systems. So the service discovery should discover them.
Yeah, it's actually already showing the exporter enabled on Minion
Okay,
2.
so maybe it's time to see some graphs. Yeah.
Sure.
Otherwise it will be too texty.
Before that, I'll go again into Prometheus. I'll refresh, and you can see we have now 3 targets in SUME system. So we have 2 endpoints for Minion 1, the node exporter and the PostgreSQL exporter that we have running there, and 1 target for Minion 2 that only has a node exporter running. Now, how can we see all this in a more graphical way? And that's where Grafana will kick in. And we'll start by showing you the SUSE Manager self-monitoring capabilities. So all the metrics that are being exposed by this set of endpoints that you have here are consolidated in this SUSE Manager health dashboard. It contains some things. It's something that will be eventually extended in the future, mainly with the possibility of drilling down in some of the panels. It already shows you the machine that you are running SUSE Manager on, what was the system load. We are here looking at the last 15 minutes, as we only have metrics since we started the session. We should actually have more than 15 minutes. Memory usage, disk space usage, what space you have on each of the mount points, how your network and disk are behaving, and then SUSE Manager internal metrics from the JVMs, so both JVM for Tomcat and Taskomatic, the database, and SUSE Manager actions and tasks in Taskomatic. So all this is visible here. And we added one example to actually drill down into the database metrics and see a bit more of insights here. I'll show you that as well. So you can see the operations on tuples separated by fetches, inserts, updates, and deletes, locks and commits, commits versus rollbacks, number of connections, and there are other things supported by the PostgreSQL exporter that could be added to your dashboards in case you need. So this is a simple example of the potential of data provided by the exporters. And
can you also show the database? Oh, that's the database of the Minion?
This is the database of the SUSE Manager server. We also have another database that Johan is configured on Minion 1 that will
do nothing.
There's not much happening here, so let's generate some load and see what happens. This will just generate random operations, inserts, updates, deletes. You can see immediately this being reflected on the graphs, especially on the operations on tuples.
So refresh interval is 5 seconds in this case.
Yeah, I'll select a shorter interval here so you can see it with a bit more definition. So it reacts immediately to what is happening here, and we could set alarms on this data if we wanted. We could do many things. PromQL here would play a very important role in all those things. Not much variation in terms of locks and connections. This is using a single connection. If If we were to use some multi-threaded load generator here, it would also affect the connections. You can see the number of commits is growing as expected.
It's just an example.
Yeah, it's just an example of what is happening here. Also, and as part of what we plan to ship later, is a template for basic data on your client systems, how your hardware is behaving. You can see here this nice little dashboard that shows our two minions, minion 2 in the first place and minion 1, and basic data, some of them similar to what you have seen previously on the SUSE Manager self-help dashboard about what is happening on the minions. Also a panel here with alerts. Hopefully we don't have any alerts, but maybe let's trigger one alert.
Yeah.
Let's
How
kill one of the minions and see what happens. I won't shut down the system, I'll just turn off the exporter, which will have the, it will simulate the same behavior. So I'll turn it off manually. I'll pick, which one? Minion 2, maybe. Okay. Whoa, it's down.
Oh, it's down, yeah.
And in a few seconds, we'll have an active alert. It's showing up quickly because I have set a low threshold, so it will only wait for a few seconds with the host down. Probably on a production environment, you'll want some higher thresholds so that you can kind of do a quick restart and not having alerts flowing everywhere. Now you can see here that there is this active alert, and this information is coming directly from Prometheus. So Prometheus is reporting a problem on Minion 2. And if we go to the Prometheus UI, you can see it's also here, instance down. And it shows, this is the template that we have for the alert. By the way, the expression that you see here, it's a very simple PromQL expression. You can use any PromQL you want here. So you can analyze load, you can analyze I/O, you can do almost anything that you can imagine on alerts as you would do to plot graphs. And this is the system that is affected. The state is firing means that, yeah, something is on fire. The system is actually triggering an alert. Alert Manager has a mechanism that can be configured, obviously, and that allows you to wait a certain time before triggering the alert. So that, for example, if you have a group of systems triggering alerts, so Minion 1 crashed, after 10 seconds Minion 2 crashed, you want to get a single alert that mentions Minion 1 and Minion 2 have crashed, not one alert for one and one alert for the other. So there is this grouping interval that will wait a certain time and will group the alerts according to the rules that you define. So it's quite powerful. And from here, Prometheus should be reporting this information to Alert Manager. Let's see. Here it is. Alert name instance down. Here's the timestamp. Here's the system that is affected. And we have this Alert Manager configured to send emails. So I might have some email on my inbox. I say I might have because I'm using a server, an email server that goes through the VPN to send emails. Hopefully it is working. Let's see.
I don't think you are connected to the VPN.
Actually,
you're
I
not
am.
in the VPN, I think.
You're right. Alert Manager is complaining it can't find the relay.
Yes.
Now I will connect the VPN and I will get an email here.
Let's hope.
In the meantime,
maybe we can restart it to make it show as up again.
Yes, true. Otherwise, this will be sending a lot of emails because I have defined a short group interval so that I get all the alerts. You will not want this on a production environment. You will want to tune the rules so that you get alerts at the right pace. And also, one thing, I don't have the configuration right here. One thing that you can define is the repeat interval. So you got an alert now about system A being down or having a high load or whatever situation was triggered. You don't want to get that continuously. You want to wait a certain time, like 15 minutes, 30 minutes, depending on what is happening there. This is also configurable on Alert Manager. It's called the repeat interval. Okay, alert
Still
manager
not
is still complaining.
being delivered. Yeah, maybe he started.
Yeah, anyway, this is just a network issue. While we wait for the email, which hopefully will arrive, do you have any questions?
Yeah.
Yeah, just a couple of questions. So, are there cases where, I mean, you're obviously using the Alert Manager here as part of the demo. Grafana has its own alerting capabilities in it. Are there cases that, in your own explorations, where you would choose to use maybe Grafana's alert infrastructure alongside Prometheus's alert infrastructure? And I would follow up after that.
We haven't considered so far the alerting mechanisms in Grafana, especially because we are also providing Prometheus, and we see Prometheus as the backend system. This is one reason, and you can then connect other things to Prometheus. And the other reason is because of PromQL. The fact that you have this powerful query language that can also be used to define alerts is a big driver for us to choose Prometheus as the alerting tool versus Grafana.
Because yeah, I've used cases where like you might have like a melt stack, and you might be using Grafana to span across those things and trigger those on that. So I was kind of curious about that. The second question is, you mentioned like integration with PagerDuty or option. I was curious in your own team, how are you? Are you using PagerDuty or using option or like is something else? Like, how do you?
Not really, no?
Yeah.
We only receive the alerts via email.
Yeah.
We send them to a mailing list that all the team or the relevant people will see,
Yeah.
so no real experience there.
Yeah. We are not
From our
managing
own.
a production infrastructure. It's our development infrastructure, which is actually relatively big, but it doesn't require a case management tool.
So you don't have to call somebody at 3 a.m. because they're speeding.
Yeah, we don't need to page anyone.
Yeah.
Yeah, but for example, the team that is running SUSE Customer Center, they are using this kind of live alerting.
Oh, here they are. So, see, this is our alert manager. It's a simple text template. You can use HTML if you want. This just contains the basic information, and you can parse the emails automatically. In case we wanted to put some automation here, actually would use the Alert Manager client tool, which can give you the very same information about the active alerts, and you can use that inside some scripting language in case you want.
There was another question in the back of the room.
Just wondering when's this going to ship, do you think?
So at the moment, this a part of what we said, showed is roadmap on the slides, but also the road is not very long. So I think you can expect most of this as a maintenance update for SUSE Manager 4, which is currently in beta 2 release. The code is going into Uyuni, and nightly builds of Uyuni will have whatever we are doing. So you can watch the progress there if you are interested into looking at the code.
Quite get that. Did you say you think it might be an initial ship of 4 or an update to 4?
Sorry, I didn't really understand that.
You're saying about the functions that you're showing. Is it going? Did you say it's going to be in the initial ship of 4 or in an update to 4?
I guess some of it will be in the initial ship for SUSE Manager 4, and remaining things will come as an update.
Yeah. And is any of this in the beta 2 right now?
In the beta 2, you would have to do everything manually. It's a bit difficult, but the packages, some of the exporter packages are available in client tools of beta 2. I think also Prometheus.
We have also Prometheus packaged, and
it could also be already in the client tools in beta 2. The formula that we were showing is already available, but it's not installed with every. You could install it manually on your server, but it's available from the beta 2 client channels, server channels. Sorry. So yeah, it's work in progress.
We also have this service discovery daemon packaged, but it's currently officially unsupported, and the plan is to actually make it part of Prometheus and upstream it. It will be a parallel effort to all the other things that we are doing.
Yep.
What would the process be for writing, for instance, custom checks that are, other than I/O up, down? If we have a custom application check that's written in say Python or Bash or something, we wanted to integrate that. What would that look like as far as the?
You mean a custom exporter?
Yeah.
Right. Why?
It's actually super easy. You just need to create an HTTP endpoint that exposes the metrics in the Prometheus format. So metric name, an optional set of labels, and the value. And that value can be any floating point number.
Yeah, and the salt states that we will be shipping, of course, they will offer you to enable the most common exporters. And if you have a very custom case of an exporter that only your company is using, you might just want to create your own salt state to install and deploy that and enable that.
An extremely simple example would be you can write metrics to some file in your system and run Python simple HTTP server and expose that file and then have Prometheus scraping that endpoint. That would work. It's an extreme example.
Be specific on the SUSE Manager side as opposed to Prometheus, or?
No, that's standard Prometheus, and I actually also encourage you. If you have something that's not like doesn't have to be closed source, make sure that you also upstream it as part of the Prometheus community.
Okay.
Because we really want to basically consume it from upstream, not do all of these.
So the role really for the system manager in this, other than the initial packaging of the installation, is to provide the exporters, I guess, enable them on the client system.
Exactly.
So once it's done that, if there's no changes, it's just irrelevant to the monitoring of the clients at that point.
Exactly. Yeah. Only that we make an effort to enhance Prometheus to easily update the configuration with the systems managed with SUSE Manager.
But once the client is set up, the idea is that SUSE Manager is not in the middle. Prometheus will communicate directly with the clients, scrape the metrics.
It's managing that process like any other client.
It's managing the process, it's automating the configuration. If you decommission the system, it will remove it automatically. It will also in the future support automatically enabling monitoring once you onboard systems. So it's supposed to help you automate all that part of the process.
And not to butt into SUSE Manager's glory, but I want to point out that we're going to be using Prometheus and Grafana all the way up the green stack. So you'll see it, you see it now in Cloud Application Platform, you will see it soon in CAS Platform and in Enterprise Storage and in OpenStack Cloud as well.
Yeah, and Enterprise Storage it's already
there. Yeah.
Integrated, and that's an example where they have special exporters for Ceph that you basically then could integrate very nicely into that dashboard if you want one view on your whole application. And going forward, when you look at my roadmap presentations for SUSE Manager, that's where we are talking about the actionable insights that Grant also mentioned today. That's when we try in the next step, but that's really on the roadmap, like a year or two from now. To correlate things in a meaningful way, like, oh, I'm running out of memory, this could cause my other service to slow down, and those things.
I think we have a question there.
I believe the system of SUSE Manager will remove it from Prometheus.
Sure. Because the service discovery mechanism is querying the SUSE Manager API for the systems that have monitoring enabled. So the system will immediately disappear from the list that gets reported by the API and will disappear from Prometheus automatically as well.
If you delete the system, all the corresponding pillar data will also be removed from the server. So.
And do you have any plan for extending the list of those exported to the underlying hardware infrastructure? Because if you see there are something like CPU, memory, and disk usage, but there will be something like all the crews, power supply, and all those thread controllers.
So I think first of all, maybe the node exporter offers some more metrics that we're not showing in this dashboard.
Yes.
So you can configure the dashboard to only show what you're interested in. But the node exporter probably collects much more than what we are showing here, right?
Collects many, many things. It has several modules. You can inclusively enable, just to state an example, the collection of smart statistics from hard drives using the node exporter. So it's quite flexible. And if that doesn't work, you can always extend it. It's open source. You can customize it very easily. It's a Go application.
You can contribute in open source to the exporters. And if you want to contribute to our formula, then feel free. So we are open to input from you for your contributions. If you want, if you have if there's an exporter that you really want to see there in every installation, and we agree with you, then we are fine to merge your pull requests.
Our plan is to include the most popular exporters to start with. And some templates for dashboards that you can use and extend. We won't put everything there because not everyone needs the same things. We'll just provide the basic templates, the basic data, and some ideas and some help on how to customize and take it further.
And you still want to keep the dashboard, the UI for Grafana differently in the SUSE Manager? Or do you have any plan to embed this UI altogether into the SUSE Manager?
So there are several reasons why we don't want to integrate this too deeply. First of all, your monitoring should even run if your patch management is down. I mean, you really want this. You may even want to have another monitoring server that's monitoring your Prometheus and Graphana, just to be sure that you get alerted when that is down. And also, sometimes the persona is a different one. Like you have these, you know, the command center where you have the big screens with these Grafana dashboards, and those are different people than the guys who may do the daily patching. What we will provide is across those features that will be single sign-on, and going forward also a role-based model where you can say, okay, if I have all those 10 servers, I can also have the Grafana dashboard that shows me those 10 servers, and I don't have to always log in. And there will be cross references, like in here, I mean, you could basically also add links to that dashboard that would then lead you to another, be it the SUSE Manager page for that machine, or also in other, let's say when you go down the Kubernetes road, you would end up in another part of the tool chain. Yeah? So that's the cross-linking is definitely going to happen, but it's not going to be one big tool that can fail as a whole. It's components that will ultimately also all be containers, I guess, and we want to keep them as decoupled as possible, and give you only like a virtual experience of a single dashboard, not an actual one where everything goes through the same HTTP server that could be down, and then you're completely disconnected from reality.
Okay. If there's no further questions, then I would say thank you a lot for your interest.
Thank you.
And I hope it was interesting to you.